We're going to look at creating a snowfall for this wintry scene. I'm probably going to fill in the sky with some more clouds, as this is quite thin and wouldn't realistically produce snowfall. But we're going to first start with the snowfall layer. We've got an emitter object, if I switch to a user view, that's suspended above the scene that's going to be providing the emission for the particles. There are a number of ways to create the emission itself, but we're going to use ice to do this, and selecting an emitter object such as the grid, we can use the ice create emit particles from selection command. And by executing this, you'll notice that a new object is created, a point cloud. The point cloud is what the ice tree is held on. If I expand the point cloud and I look at its list of properties, a point cloud consists of a number of construction stacks, and in our case we have an operator, an ice tree that has been built for us, added to the simulation level of the construction stack. This means that all the information from the ice tree is calculated at one frame and then applied to the next frame, and this is where we get the particle motion. We can set up all of our complex interactions such as gravity, forces, etc. using the simulation construction stack. If we actually select the point cloud and open up an ice tree, I'll press the refresh button and you can see the mimicking of the mini explorer on the right side of the ice tree. In fact, we can use these show hide menus to toggle the presets on the left side or the explorer on the right if you need more room. So we have our snowfall that's been brought in as an emitter object, our snowfall emitter. That's our grid right here, and we can actually do that by dragging it right from our explorer in, and we've actually got the same node, as you can see. So that's kind of what the command has done, is it's used the selected object and plugged it into an emit from surface compound. So this is the object that's acting as the emitter, and our emit from surface is driving the first port of our ice tree. These are the roots of your trees, and all of the complexity you build into your graphs will terminate here. The ice tree is read from top to bottom. Basically, it goes out and branches out from bottom to top first of all, and it searches out information along the branches, and then once it gathers all of that information, the information is fed back down the branches and evaluated and executed from top to bottom. So we usually want to start with first things first, second things second. So we're emitting particles from the grid in our first input, and then we're simulating the particles, which is simply a way of saying take the information from the first frame and apply it to the second frame. We have an initial state for the particles. All the particles are initialized with various attributes such as speed, direction, size, and color, and then after the first frame we can modify those. If we want to affect the changes at emission, we plug compounds or nodes into this emit from surface port. In other words, if I wanted to modulate size with some sort of a random value, I could set that for the second frame, for the emission frame. But if I wanted to change that value over time, this is where you would use the actual ice tree. The ice tree allows you to use compounds or nodes and have their values accumulate over time or blend over time, depending on what kind of connection you're creating between your compounds and nodes. So if you don't want to build it that way, you can also build it the manual way. I'm actually just going to delete this point cloud, and as long as we have an emitter, we can build our point clouds manually. We can choose from a preset shape or use an empty point cloud, which is usually what I would go with when I want to build my own kinds of particle effects and I'm using grids as emitters or nulls as emitters. I'm going to actually take the point cloud, and from the ice tree pull down menu, the C view here, Alt 9 if you want to use your hotkeys, I'm going to just create one of two ice trees. If I want to create a particle ice tree where the previous frame gives its information to the next frame, or let's say the current frame draws its information from the previous frame, we want to create a simulated ice tree, which will create an ice tree in the simulation construction stack of the point cloud. So if I do that, we have our little mini explorer appear. Point cloud contains a simulation construction stack, and we have our ice tree sitting there. So the ice tree operator is represented by the root of the ice tree in the ice tree view. So we have a number of ports that are available to us. Actually, we have as many as we want. We can just right-click on a port and insert additional ports before or after the one we're right-clicking over. So we can usually start off with a few ports, and I'll begin by emitting particles. We need to choose what kind of particles we are going to emit. Are we going to emit from a null, a curve, a surface? Are we emitting from a three-dimensional volume? If I look under my list of tasks, under particles, I have a category called emitters, and I'm just going to emit from the surface of another object. So I'm going to pull that compound, which is represented by a little toolkit with gears, and I'm going to plug it into the first port of my ice tree. This is the first thing I want to do, emit particles. The compound's red because it doesn't have information that will allow it to really pass any meaningful information to the base of the ice tree in port 1. What I need to do is provide an emitter object. You can see it's looking for a certain type of input, and that input is going to be the object itself. So I can actually take the Snowfall emitter, which is a polygonal geometric object, and I'm going to drag and drop it from my Explorer into the ice tree and essentially just get its value. I'm just getting the entire object. I can output the object as the emitter, which resolves the emit from surface compound. It turns to its nice kind of tan color here. Now when I emit particles, if I hit play and I just look in the user view for a moment, you can see the particles are emitting, but they're not going anywhere. And the final piece of the puzzle is to add another node at the root of the ice tree that calculates the previous position of the particles to figure out the next position. To do that, we're going to look in our list of tools. These are some of our core tools for building effects. And if we look under the simulation category, we're going to use a simulate particles node. The difference between simulate particles and rigid bodies will be apparent in other tutorials in these modules, but essentially simulate rigid bodies have interparticle collision detection and will actually build up on top of one another if you were to pour them into a contained medium like a cup. So it's a start for being able to do fluids or kind of gooey, slimy things. Particles do the same thing as well. In any event, we're going to use a simulate particles node as the last port on our ice tree. So we want to grow particles, initialize their size, color, shape, direction, speed, and take the previous frame and add the values to create the position for the next frame. And so we have that very thing going on here. I've set the start and end frames from 1 to 5,000 so we can get a sense of how the particles are working. Now the problem here is that the particles are moving up and they're yellow, and so this is just the first step, creating the emission. We're now going to expand upon this ice tree and add some additional functionality to it to make the particles look and feel like snow. This is also going to involve some rendering and compositing as well, so it kind of takes you through the process of how particles are used throughout a pipeline.